Part 3 is going to extend the fact that we're dealing with functions still. And now we're going to kind of take our equation that we did in the last segment in part 2, and now we're going to expand on that now and see some examples of what this really does. So I hope that you're really getting to pay attention to this and you're kind of seeing this a little bit. You might be like, I'm still confused, but hopefully as we go on, you're going to look back at your notes from part 1 and say, okay, now I see the segment. All right, so remember, a function is for every input, I get something out. For every input, I get exactly one output. For every input, I get an output. And we're going to see more of this function later on and see where it doesn't always become true. Sometimes there's functions out there that are not functions. They're trying to be, but they're not. And we will see that later. So a couple more definitions or words that I kind of want you to kind of see and get used to is what we call a domain and what we call a range. Now, just to be very careful and clear about these, let's make these simple. A domain is just all the x values. It's pretty much saying that all the x values. So all your x-axes. So you can put over here, maybe you should say the x-axes. The x-axes. So that's your horizontal. You can also put a horizontal if you want. The range is the y-axis. So you can say all the y values. And so you can probably say you can say all the y values or y-axes. So the domain, if I say what's the domain of this function later on, you can tell me it's all the x values, but what if there's a limitation on the graph? And sometimes you can't use all of the x-axes. And that's kind of what we're getting into also. What can we use and what we can't? And this will make sense later. So we are trying to use that formula that we developed on the last segment, that rate of change. Remember, this is what we call the rate of change. If you need to review, stop this, go back to number 2, part 2, and go back to this again. But this is our equation for rate of change. And that's what we're going to be using for a while now. Because that's the big concept, rate of change. But it's also going to be called something else, this segment. So let's look at an example, or a few examples of where we use this. So I'm going to give you 2 points. So I'm going to say, let's do maybe 2 points. So 1 and 2. So first off, let's make them easy. 1, 2, 3, 4. So these are 2 points. I want to use our equation to find the rate of change between these 2 points. These 2 points, point 1 and point 2. I want to see the change between those 2 points. So let's go ahead, and here's how I want to start. You have to have 2 points to determine a line, right? You ever heard that expression that for every 2 points there's a straight line that exists? So from here to here there's a straight line. So before we get started with our 2 points, I want to be very careful and to make sure we're using them properly. So I want you to call this first point, remember this is x1, this is y1. What's the next point? Well, this is x sub 2, y sub 2. Remember, this is going back to that first video where we watched that we had made those 4 points and we called them all by sub because we had 4 points. Well, we have 2 points. So here we go. I want you to really get this equation down in your head. So here's what I want you to do. Always rewrite this equation to a certain extent. So I'm going to go y2 minus y1, x2 minus x1. I'm always going to rewrite my equation, my rate of change, because this is pretty much what you're going to take to make your rate of change. So now, here's what I want you to do. I want you to be very careful what is always going to be there? What is always going to be here in this equation? And I'm hoping that you're saying the negatives. There's always going to be minuses there. Negatives, that's fine. But there's always going to be minuses there. Always. Those are always there. So when you rewrite this equation, you're always going to have something like this. It looks like a division, but it's not. This is the minus signs. Now, what are you going to put in to this part right here? What are you going to put in right here? Well, that's the y2. Well, where's the y2 on here? Where is the y2 in these 2 points? And I'm hoping that you're saying right here. Here's y2. So you're going to put 4. So you're going to put 4 there. Now, go back over here. Where's y1 at? Where's y1 at? Or maybe y sub 1. Isn't it right here? Y sub 1, that's that one. So put 2. Okay? Go down here. Where's x sub 2 at? Oh, x sub 2, that's 3. Where's x sub 1 at? Okay. Put that right there. Now, can you do the math? What's 4 minus 2? 2, right? What's 3 minus 1? 2, right? What's 2 divided by 2? 1, right? Or 1 whole. Could I rewrite it 1 over 1? Isn't this the same thing as big 1? Yes. So, that's what we call the rate of change. So this is what we call the rate of change. So we can say that rate of change between these 2 points, the rate of change between these 2 points is 1 over 1. So that means that I rise and run by 1. That means I do something like this. You don't have to write this down, but I want you to look at this. What does this mean? This means that I go up 1, go over 1. Can I keep going? second. That looks like almost like a staircase going up. So I rise and run. Oh, so this is saying that this is like a pattern to get to the next point. Yes. And that's what we're trying to accomplish here. We're trying to form a pattern. And what we call our rate of change is actually 1 over 1, which is that staircase. So we want to get to the next point, maybe point 3. But we can actually use this now to get to the next point. And that's kind of what we're trying to do. We're trying to predict and get to the next point. All right. Let's try it one more. Okay. So this time, I would probably take this out. You can probably take it all out because we're not going to use it. Because different problems, different points, have different rates of change, obviously, right? So now let's do something with this. So what about if I gave you -1, -2, 1, 2. -1, -2, so that's negative. So let me just draw you a picture of what that is. So here's our x, y. We're going to go -1, -2, so we're down here on the xy axis. And up here, we're about up here somewhere. So we're trying to get something like that. Okay. So here's the objective. Here's our 2 points where we did x1, x2, y1, y2. And now, remember what I told you? Always write down the equation until you get really used to this. And just fill stuff in. So, what's always going to be there? The minuses. And now, just go ahead and what's x2 or what's y2 in this case? Well, let's see. Y2 in this case, after you wrote these down and did all this, you should be always doing this. You should always be writing these down to help you mentally to see this. So, what's y2? Well, y2 now is going to be 2. Minus, what's y1? -2, so -2. What's x2? x2 is here. It's 1. Minus, what's x1? x1, -1. There you go. Now, just go ahead and simplify or do your numbers. So this should be 2 minus -2. Remember this right here can turn into a positive. So that's going to be 4. And what happens here? Positive. Now what's 4 divided by 2? 2. Or, you always have to have this. You always have to have a fraction in this. And that's something you might want to note down, is every time we do a rate of change, it's always a fraction. So, it's always going to be a fraction because you have to have that rise over run. You always have to have that rise over run. Remember that? So this is 2. Well, what does that mean? You change this, right? The rate of change between these 2 points should be 2 over 1. Okay, make sure you change that. And it's always a fraction. Now, what does this 2 over 1 mean? So that means I'm going to start here, and I'm going to go up 2. 1, 2. What does this 1 mean? This 1 means I'm going to run by 1. Keep going. Up 2. 1. Up 2. 1. You kind of see the pattern? And I tell you what, it's a staircase. And that's kind of what's going on with this. You are trying to develop some sort of equation, and just off of 2 parts. Now, let's take this one step further a little bit and finish it off. In this table here, we have rise and run. We have rise and run. Remember, we have our y's and our x's. What if I gave you 2 numbers? What if I gave you 2 numbers? And you should be writing this down to kind of help you out. What if I gave you 2 and 4? 1 and 2. -1, 3. 0 and 1. What if I gave you those numbers? Can you tell me what our rate of change is? Can you tell me what this rate of change is? Remember, this is what we call the rate of change. Can you tell me what this is? What this is? Remember, it's always going to be what? Rise over run. So what's the rise? 2. The run is what? 4, right? Can you reduce that? Is that 1/2? What's the rise here? 1. What's the run here? 2. What's the rise here? -1 divided by what? 3. What's the rise here? 0. What's the run here? 1. Do you remember what 0 divided by 1 is? It's 0, right? It's 0. If it was the other way around, if it was 0, if it was you can't divide by 0, then you have a question. Then that's a problem. But be careful. But I'm hoping that you're seeing that each rise over run gives you different rates of change. And we're going to call this something else. So on the next part, we are going to call this something else. And that's pretty much what we're going to be calling it throughout the year. So hopefully that this wasn't too much. This is pretty much the big part of this, because you have 2 points, you're trying to find the rate of change. And be very careful, always rewrite this and don't forget the negatives. And hopefully that's it of this. And watch it again if you really get stuck on this. But I'm hoping that you're kind of piecing these together a little bit. And that takes active learning and active listening, and not doing 5 things at once. It's called focus, narrow focus, laser focused to this. So I see you in the next one.